Okay, so now we're working on number 10 in this case. And number 10 is talking about a white guinea pig with straight fur or straight hair mating with a brown curly-haired guinea pig. Alright, so let's make just a little written description. We've got white and straight hair. We'll cross that with brown and curly hair. Brown and curly. Okay, so it tells you a lot about their babies. It says, okay, there's 5 babies in the first litter with brown fur, 3 curly-haired, 2 straight-haired. Second litter has 6 more offspring, brown, and 2 are curly and 4 are straight-haired. So what I'm going to do is I'm going to make a list of all the things I know. So I'm going to say, let's talk about colors here. We'll talk about the colors of the guinea pigs. So first, we have brown. And I know that even though the brown guinea pig bred with a white guinea pig, all 11 of their offspring have brown hair. That means for white, there's none of them that have that brown fur, or 0 out of 11 have white fur. 0 out of 11. Okay. For curly fur, I can count up how many they have. I see in the first litter, I see 3 curly-haired. In the second litter, 2 more curly hair. So I can take this and say, okay, 5 out of the 11 have curly hair. And for straight hair, that must mean the other 6 had straight hair. So almost half and half. Six out of 11. Okay. So the first question is, assuming that curly is dominant to straight, what are the genotypes of the parents and the offspring? Okay. Curly dominant to straight. So I know that the white straight-haired guinea pig, well, if he's straight-haired, he must have 2 recessive alleles. So I know that we'll do an S for straight, a little s for curly. Okay. And then I don't know for sure yet what the color genotype is. I'm crossing that with a curly-haired guinea pig. I know that the curly-haired guinea pig, it has curly hair, so it has to have at least 1 dominant allele. So it has to have at least 1 big S. 1 big S for curly. Okay, but I see that half of their offspring have curly hair and half have straight hair. And if I gave them both dominant big S's, then there'd be no chance of them ever having straight hair. So that must mean that he has a straight hair allele hidden by that curly hair allele. Okay. The next part we need to look at is brown and white. So we bred the white guinea pig, but we ended up with no white offspring. So if we have no white offspring, that's going to mean that brown is dominant to white. So for sure, this white guinea pig, or the straight-haired guinea pig, it's going to have little b, because we didn't end up with any white offspring. But the next question is, I know this brown curly-haired one, it's got to have a big B. I know that it has at least 1 brown allele. But since we didn't see any white offspring at all, I know that it has both big B alleles. That's for letter A. This is our genotype of letter of our two guinea pigs. Letter B is asking, what is the probability of getting 2 female guinea pigs with straight hair? So now it's asking us to ignore the B's for brown and white. Now we're looking at male and female. So we're still going to keep S, little s, little s. And we're still going to cross it with a big S, little s. Or no, yep, big S, little s. But what we need to do now is look at our sex chromosomes. So we know one of them has to be a male. So it's going to have an X and a Y chromosome. And one's going to be a female. So it's going to have 2 X chromosomes. Okay, so we need to FOIL out our genotype in order to get our gametes. So we're going to have a little s and an X. Sorry, let's say 5. We're going to have a little s and a Y. We're going to have another little s and an X. And another little s and a Y. That's our 4 genotypes, or our 4 gamete formations for this combination here. Over here, we're going to have a big S and an X. And we're going to have another big S and an X. We're going to have a little s and a big X. And we're going to have another little s and an X. So you're going to cross those 2 things in order to figure out, you're going to take your 4 gametes, line 4 of them up on the top, 4 of them up on the side, in order to determine what the chance of getting 2 female guinea pigs with straight hair is. Alright, we're going to move on to number 11 at the same time, but we're going to do it on another sheet right here. We're going to start painting from scratch. We're going to go this guy. Okay, we're going to do number 11. So number 11 has a lot of information in it. It says about 70% of Americans get a bitter taste from the substance called phenylthiocarbamide, or PTC. It is tasteless to everybody else, so 30% of the population. We know that the taster allele is dominant to the non-taster, so we can make a big T dominant for taster. Dominant to non-taster. Okay. And we also know, this is like a whole nother idea, that normal skin pigmentation is dominant to albino. So it was talking about people tasting things, now it's talking about skin color. So our other fact that we know is that we can have skin pigmentation, normal skin pigmentation, or a little s, we'll do that for albino. So normal skin pigmentation just means having melanin in it, having the colors that make your skin color the color it is. Albino is just a very, very, very white person, somebody that has no melanin in their skin tone. Yeah. Okay, so the next thing we know. A normally pigmented woman who is taste blind for PTC has an albino taster father. Okay, so normally pigmented woman, but she has an albino father. So first thing we know she has at least 1 dominant allele for skin color because she is a normally pigmented woman. But we see she has an albino father, and so if he's albino, he must have 2 recessive alleles that he passed on, at least one of them, to her. We also know she's taste blind for PTC. If she's taste blind, that means she has 2 recessive alleles. So this is for our woman. Okay, and and she is going to marry a man that is a taster, but his mother is a non-taster. So if his mother's a non-taster, she has 2 recessive alleles. So she must have passed on one of those recessive alleles. So even though he can taste, he has at least 1 recessive allele. And we also know that he is an albino man. And if he's an albino man, he has both recessive alleles for skin color. We'll give him a green. This is for the man. So the next thing we need to do, so those are the genotypes of the parents, and that is what we need to do in order to figure out the offspring of this couple. So, in order to figure out the offspring of this couple, we're going to figure out the gametes of the woman and the gametes of the man. So for the woman, this first S could combine with the second T, or with the first T. So we could have a big S, little t. It could also combine with the second one. Big S, little t again. We could also combine little s with little t. And we could also combine again little s with the second little t. Okay, for the man, we're going to combine our little s with our big T. Our little s with our other little t. Again, little s with little t for the second little s with the first big T. And then again, little s, little t. Okay, and then to figure out our expected offspring of this couple, we need to put our 4 gametes at the top of our Punnett square and our other 4 gametes on the side of our Punnett square, and then we'll cross those 4 gametes with the other 4 gametes to get our offspring.